we have come to the final part of 2026 January Chemistry Unit 5 paper. We have question number 15. It says, this question is about the reaction scheme shown. So they have given us a reaction scheme. In the first step, this scheme, the yield is relatively low due to the formation of side product 1, which is 1-chloro-2-nitrobenzene. Okay, they have given us both the structures. So they have given us the structure that we see, and they have given us the structure of this byproduct or side product. Okay, now they are asking how many peaks are present in C13 NMR spectra. So in next video, I'm going to plan to talk about this NMR spectroscopy to give you a right idea. But C13 NMR spectra simply means how many different types of carbon atoms you can find in a given molecule. So I'll take these two molecules. So we have the main product and then we have the side product. So that means we have to simply find how many different environments of carbon atoms you have here. Let's go for this side product. Okay. So this is one carbon environment. It is attached to a chlorine atom. I don't see any other carbon atom attached to a chlorine atom to at least to check whether there are similar environments. So this is one type. So I just call first environment. Then we have a carbon atom attached to this nitrogen atom, NO2 group. So I don't see any other carbon atom attached to a nitrogen atom. So that's the second environment. We have only one carbon atom there. Then I can see another carbon atom here. In this carbon atom, you can see that it's attached to a carbon atom with nitrogen atom. So there's only one carbon which is attached to hydrogen and which is attached to carbon with NO2 group. So that's also only one environment. That's my third environment. And if I go for this one, okay, a carbon atom attached to hydrogen, one side is CH, CNO2, because this is the only carbon atom which you can find which attached to CH and CNO2 group directly. Because if I go for the next carbon atom, I'll take this one as an example. It doesn't attach to CH, CNO2. It's just attached to CH, CH, CNO2. So that means these two are two different environments. So therefore, this is my fourth environment and this is my fifth environment. And the next carbon atom is directly attached to a carbon which is attached to a chlorine atom. So this is another environment. So definitely in this molecule we have 6 carbon types of carbon. That means 6 carbon environments. So if you have 6 different types of carbon, you will see 6 different peaks. So therefore, obviously, for this side product, the number of peaks is 6. Now we know the answer. Our answer for question number 15 is D. Question number 15A is D. Now you might be thinking, then why this is 4? There's a reason. Okay, let's take that one. Carbon is attached to chlorine is the first environment. Carbon directly attached to the nitrogen NO2 group, that's the second environment. But if I take these two carbon atoms, which one? This carbon atom and this carbon atom. Why is that? Because this carbon atom attached to hydrogen, one side is CNO2 group, other side is CH, CCl. This carbon atom also, one side is CNO2 group, other side is CH, CCl. That means both of them are in the same environment. So that's my third carbon environment. Let's go for next one. If I take these two carbon atoms, same story. One side is CCl, other side is CH, CNO2. This one also, one side is CCl, other side is CH, CNO2. So both of them are in the same environment. That's why this molecule has 4 environments and the side product has 6 environments. So our answer for question number 15A is D. Question number 15, part B. Which acid is not used as one of the reagent in the reaction scheme. So let's see what is the reactions we have. What are the reactions we have? First one is a nitration reaction. So for that we need concentrated HNO3 and concentrated H2SO4. Then NO2 becomes NH2. You need tin and concentrated HCl, hydrochloric acid. Then NH2 becomes COCH2CH3. So this is what happens here. This is the NH2 group. To make it COCH2CH3, you need acid halide. So you need acid halide as an acid chloride. This is chlorine, CH2, CH3. What happens here? This hydrogen and this chlorine moves out as HCl molecule. This is a chlorine atom. So when it removes as HCl, what you get here is, so now you have the NH group is there. Now our carbonyl carbon get attached to this nitrogen atom, and then you have CH2, CH3. So that's how you get this NHCO, CH2, CH3. So that means here you have to add acid halide, CH3, CH2, CO, Cl. So we need to add sulfuric acid, yes. We need to add nitric acid, yes. We need to add hydrochloric acid, yes. But we don't need to add ethanoic acid. We need ethanoyl chloride. So answer for question number 15 part B is A. That's the answer. Now let's go for question number 16. A complete combustion of hydrocarbon produced 1.32 grams of carbon dioxide and 0.45 grams of water. Which is the empirical formula is consistent with these data? Okay, let's see that one. So let's assume it's a hydrocarbon. That means it contains carbon and hydrogen only. When a hydrocarbon reacts with oxygen, because it's complete combustion, we get carbon dioxide and water. But there's a problem. We don't know how many carbon atoms we had in the hydrocarbon. So I'll call it X number of carbon atoms over there. If you had X number of carbon atoms, you get X number of carbon dioxide, because left and right hand side should be balanced. We don't know how many hydrogen atoms were there, so I'll call it Y number of hydrogen atoms. If you have high number of hydrogen atoms, number of water molecules should be Y. No, because Y get multiplied by 2 because it's H2O. So I have divided Y by 2. Y by divide by 2 multiplied by 2, it becomes Y. So number of hydrogen atoms get balanced. If you do the same concept, you will find the number here in front of oxygen as X plus Y divided by 4. You don't need to worry about that one at this point. Okay. So we burn the hydrocarbon. Now we have the balance equation. CXHY give us XCO2 and Y divided by 2 H2O. And the masses of each product is given. Mass of carbon dioxide produced is 1.32 grams. Mass of water is produced is 0.45 grams. But we need to find the empirical formula. To find the empirical formula, we need the simplest mole ratios. Let's find the number of moles. We know number of moles equals mass divided by molar mass. So number of moles of carbon dioxide is, mass of carbon dioxide is 1.32 grams divided by molar mass of carbon dioxide. Carbon is 12. Oxygen is 16. 16 times 2 is 32. 32 plus 12 is 44. Molar mass of carbon dioxide is 44 grams per mole. So same thing if I do it to water. If I do it for water, water is mass is 0.45 grams. Molar mass of water is, oxygen is 16. There are 2 hydrogen atoms. 16 plus 2 is 18. So 18 grams per mole. Right. If I do this calculation, number of moles of carbon dioxide is 0.03 moles. Number of moles of water is 0.025 moles. Right. So when you see a number like this, you remove these decimal places, then you will see the what you can what is the real ratio. So if you do that way, I can see there are 3 decimal places. I just take them out, multiply both sides by 1000. So I multiply this side by 1000 and multiply it by this side also by 1000. When I multiply 0.03 by 1000, it will become 30. 0.025 by 1000 is become 25. 30 to 25, you can see the simplest ratio. Yes, this is 5 times 6 is 30 and 5 times 5 is 25. Alright, so I get the ratio. Now these numbers x and y divided by 2, those are the mole ratios. So x is to y divided by 2, I got the ratio is 6 is to 5. That means x is 6. Then what is y? You have to y divided by 2 is 5, no? So y should be 5 times 2, it should be 10. Now I got what is x and what is y. So our answer is C6H10. No, that's not the answer. Why? There's a bold letters. If you see in your question any word in bold letters, you have to be very careful, because they are talking about empirical formula. Empirical formula means simplest ratio, C6H10. The simplest ratio between 6 and 10 is 3 and 5, because you can divide this both numbers by 2. So therefore our answer is C3H5. So question number 16, answer for this question is C. Question number 16, answer is C. Let's go for question number 17. Okay, the reaction to produce a solid organic compound resulted in formation of an aqueous solution. You are focusing to produce a solid organic compound, but you end up getting an aqueous solution. Now your product is there, organic compound is there. Solvent extraction is used to separate the organic compound. Desirable properties of the solvent include that it is. Right. First we'll see what is this solvent extraction. For that I just tell you a story. Let's say we'll take a scenario. You have an aquatic plant, marine plant, right? In this marine plant, we suspect that there's iodine inside these leaves. I want to take this iodine extract out. Why I take iodine? Iodine is a non-polar as an example, because if you take most of the organic compounds, they are also non-polar. So assume this iodine is behave like your organic compound. So first thing is I have to take this iodine out from these leaves. So I have to grind them. I use mortar and pestle. I grind them with little bit of water. Then only you can take this iodine out into an aqueous solution. After I filter these solid leaf particles, I will end up with the aqueous solution of iodine in water. The problem is water is a polar solvent. Iodine is non-polar. Just like your organic compound, iodine is non-polar. So what I'm going to do is, for this one, then I take this aqueous solution in a separating funnel. Separating funnel is a structure like this. It has a tap at the bottom where you can take any layer out. On top of that, I'm going to add hexane. Why do I add hexane? There's two things. One thing is, hexane is completely immiscible with water. So therefore, when I add it, I will get two different layers. One is an aqueous layer, other one is a hexane layer. So first property is they should not mix with each other. Right. Then the second thing is hexane is non-polar. Why I use non-polar liquid solvent? The reason is non-polar iodine, just like your organic compound, favors non-polar solvent. So therefore hexane is a non-polar solvent. Most of the iodine, almost all the iodine, most of it, right? It's not complete, but some of iodine might remain in the aqueous phase. But almost all of them will end up going into this hexane layer. So then what I'm going to do is I'm going to open the tap and I can remove this water layer. Then I can get the iodine dissolved in hexane. Then I can evaporate or distill off this hexane to get the iodine. Same thing we are going to do. That's the basic concept of solvent extraction. Now let's see what are the answers they have given. First point, they are saying that describe the properties of solvent include that it is solvent extract miscible with water and dissolves the compound fully. No, I don't want that solvent to miscible with water because I won't be able to get these two layers in this inside the separation funnel. So therefore first one, no. Immiscible with water, that's correct. Dissolve the compound fully. Yeah, that will be a good thing because if I can dissolve my compound completely in that new solvent, then I can extract all of them. But it's not going to happen like technically, but if it happens like that, it's really good because we expect almost, so almost all the compounds will dissolve. That's what we are expecting. So answer B is a good one. Miscible with water, no, we don't want our solvent to new solvent to miscible with water. Immiscible with water and partially dissolving compound, no, I want my compound to dissolve almost completely. So rather than say partially means is less soluble, but they are saying that compound fully, that makes sense. So therefore, so now they are saying the most suitable answer, right? B is not the 100% scientifically accurate answer because you can't find any solvent where all the non-polar organic solvent will end up there, but we want to almost all. So therefore we can use this word fully. So therefore answer for question number 17, most suitable answer for the question number 17A is B. Next question, question number 17 part B. The resulting impure compound is purified by recrystallization. Okay, we should know what is recrystallization. When recrystallization is used to purify a solid, which is the following statement is true. Before anything else, we should know what is recrystallization now. So I'll discuss recrystallization of benzoic acid using water. Right. Why we use water for recrystallization of benzoic acid? This is the scenario. Now let's take this is benzoic acid. I'm going to use a solvent. This is the requirement of this solvent, right? When the solvent is hot, that means when it is warm, the benzoic acid should dissolve in it. But when the solvent is cold, the solubility of benzoic acid should decrease. That means we can say benzoic acid should not dissolve in it. That's the requirement we need to purify a solid through a crystal through recrystallization process. When the solvent is hot, the crystal should dissolve there. When the solvent is cold, crystal should not dissolve there, or their solubility should decrease. What is the reason of this one is, that's the concept here. And here we use benzoic acid is because this ideal solvent for benzoic acid for recrystallization is water. Water is a solvent that we can easily find. That's why we are discussing this one. Why we use water? This is the reason. When the water is hot, benzoic acid dissolved in it, and the water is cold, benzoic acid is insoluble in that solvent. Okay, now let's see how we can going to do this. Okay, we have benzoic acid here. Benzoic acid can come up with two different types of impurities. One of them are more soluble than benzoic acid. We call them soluble impurities. Other one is impurities which are insoluble than benzoic acid. We call them insoluble impurities. Now what we are going to do is we dissolve maximum amount of this benzoic acid sample in hot water. What will happen when we use hot? Benzoic acid dissolves. We just discussed. Benzoic acid dissolves when the solution is hot. So therefore we can expect benzoic acid to dissolve there, right? So benzoic acid will dissolve there. Not only benzoic acid. See, benzoic acid is now in the solution. Not only benzoic acid, something else will also dissolve. Soluble impurities. If they are more soluble than benzoic acid, obviously they will also dissolve there. Soluble impurities will also dissolve there. Then who's not going to dissolve? It's the insoluble impurities. Now they are remain at the bottom. Now I have to do the filtration. I have to do the filtration while this solution is hot. We call it hot filtration. For that I take a warm funnel, warm conical flask. How I can get a warm funnel? Till we start that in like filtration, we keep this glass apparatus in a hot water bath. Whenever we want to do the filtration, we do it. We do the filtration fast. Now the insoluble impurities are removed from the solution. Now we end up with only the benzoic acid and soluble impurities here. Now you immerse this sample in an ice bath. So what we learned, when the solvent is cold, benzoic acid will not dissolve there. So when you immerse this conical flask in an ice bath, benzoic acid will crystallize. But the soluble impurities, their solubility is higher than benzoic acid. They won't dissolve. They will remain in the solution. Now I have to do the filtration while the system is in cold. We call it cold. We can call it cold filtration, but it's impossible to do the cold filtration. We can't do the filtration in a fridge or anything. So rather than cold filtration, we come up with new one. Why? What if we do the filtration so fast before the temperature rises up? To make it fast, we go for suction filtration. So in this setup, we have a suction pump. We have side arm in the conical flask. There's a suction pump. When it keep on removing air inside the conical flask, what will happen? From the funnel, the gas will get sucked inside. As a result, the filtration is so fast. Then I get benzoic acid crystals in the funnel. This setup we call it Buchner funnel setup. Okay, from that way I can get the benzoic acid crystals, which are pure. It says the resulting impure compound is purified by recrystallization. When recrystallization used to purify a solid, which of the following statement is true? All impurities must be insoluble in the solvent used. All impurities must be insoluble in the solvent used. No, we want our soluble impurities to dissolve there. They say all impurities. Wrong. Because soluble impurities do dissolve there. We just discussed here. Soluble impurities dissolve there. So that's wrong. All impurities must be soluble in the solvent used. No. All impurities must be soluble? No. Can you remember? Insoluble impurities did not dissolve there. So all impurities must be soluble. That's also wrong. Insoluble impurities are removed by filtering a hot solution. Yes. Yeah. Hot filtration, we remove the insoluble impurities. That's correct. So we know the answer. Answer for question number 17 part B is C. Soluble impurities are removed by filtering hot solution. No. Soluble impurities are removed by filtering the cold solution through suction filtration. So therefore answer for our question number 17 part B is C. Right. Then we finish Unit 5 paper 2026. Then we'll discuss the last few exercises that you can do for neurogenesis. Speaking with people regarding their passion or hobby. So there are some people, they are like so passionate about it. When you talk about it with them, you will learn a lot of things from them because they will share all the knowledge that they have on it. And that will trigger your neurons. Read non-fiction books where you can learn new things and make notes on it. Non-fiction book means these days you can learn about this geopolitics, history, and now only people know about this petrodollar system, why the USA does not want to leave this Gulf region. All this stuff is really interesting to learn, and you will learn new things because as a science people, we only focus on science knowledge. It's not like that because the world is linked with economics. If you are a scientist, if you're going to be a scientist, if you're going to be a scienceman, you should know how the finance works. That's the main weakness most of the scientists are having. And also, it improves your knowledge. Watch a new TV program or new YouTube channel. Find a new YouTube channel, something regarding a news channel or something which you haven't learned, you haven't touched these days. One thing you can learn about what is this great game theory. There are plenty of like one example of this TED is a very good YouTube channel. You can watch those stuff to learn new things. Take an online course. Now at the moment, watching this video is just like you are doing an online course. You can take new courses, and that's also help you for neurogenesis. For one day, only ask question. Just make sure on one day you will only ask question. The people will think you are a good listener. But actually what you are doing is you are keep on generating questions. You know that one point of creativity, one sign of creativity is a curiosity. But you are curious till your age 10, 11. And then because of this competitive setup in the education system, you lost that curiosity. If you keep on asking questions only, that you can develop that curiosity inside you. And another thing, a very fun, play yes or no game with child. You know this game. So that's actually train your new thinking level and neurons. That's a good training. So always try to win. So yes or no game with the child. That's a really good. Make imaginary association to remember things. If you want to remember things, now let's take you want to remember a reactivity series or any other things, colors. Make some imaginary things. Create something that you can remember. For an example, if you take copper sulfate, you are adding ammonia. First, what will happen? You get a blue dragon. Blue dragon means something rocky. All right, blue precipitate. Then if you keep on adding ammonia there, what will happen? It will form a blue pterodactyl which can fly. Okay, so that means the solid precipitate disappears, forming a blue solution which can. Okay, likewise you can create imaginary story to remember things that will help you to wake up the neurons. Actually your neurons are working. Even if you, for an example, let's assume a person is blind. People think the area which is the related to visual things, visual cortex, they are think that those neurons are not working. No, what the brain will do is they will assign those neurons for some other task. So what will happen? You will keep on assigning your neurons for any unused. You don't have any unused neurons in your brain. What you have to do is you have to make sure that neurogenesis and neuroplasticity, you have to train those neurons or do new things. And the last thing is, after you finish the exam, you can write a poem or small article or a book. Definitely write it. That will help you for neurogenesis. Okay, with that we finish Unit 5, January 2026. I have finished all the papers that we can discuss in the MCQ section for 2026 January season. And then what I'm planning to do is I'll definitely do this May June examination as well when you finish the exam. And there are some requests. I'll take 1 or 2 requests from them. I will discuss those questions and teach you with those theory parts. If you learn anything from that, if you want to learn more from me, just subscribe or leave a comment. I will respond to you. Thank you.